Good morning, students. In last class, we are discussing about alcohols, phenol, and ethers. And we are at the end of this topic. Today, we shall discuss about the preparation and chemical properties of ethers. See, you know, as ether is a functional group which contains both the sides an alkyl or aryl group with an oxygen atom, and you are familiar to write its IUPAC name and some more basics of ethers we already studied even in classification and IUPAC name. In this class, we shall discuss about the chemical reactions for the preparation of ether and as well as their chemical properties. See how ethers are prepared. Preparation of ethers. We shall study first preparation of ethers. Preparation of ethers. See, in the preparation of ethers, you are going to study only two important methods. That is, first one, from alcohol. See, when alcohol is heated with a protoic acid at a particular temperature, we know as ethers are heated at, the alcohols are heated at 443 Kelvin temperature in the presence of a protoic acid, and alkene is formed, which is nothing but acid catalyzed dehydration of alcohol. But as a reaction condition, just to change, when alcohol, preferentially primary alcohol, is heated in presence of a protoic acid at 413 Kelvin temperature, ethers are formed. So I'm going to write this reaction. Say CH3, CH2, OH. So which is nothing but ethyl alcohol. When ethyl alcohol is heated at 413 Kelvin temperature in the presence of protoic acid like H2SO4. Instead of sulfuric acid, we can use orthophosphoric acid also, H3PO4. See, we will get CH3, CH2, O, CH3, CH2, CH3. So, diethyl ether is obtained. If the reaction condition changes to high temperature, so it is at a moderate temperature. If it is high temperature, we will get alkene. We will get alkene. You studied this reaction. So this is nothing but a dehydration mechanism here completed. See, in this reaction, you take just two molecules. In this reaction, here alkyl group should not be hindered. There should not be any disturbance to an alkyl group. And at a particular temperature, particularly less temperature, the ethyl alcohol is converted into diethyl ether. What is the name of this compound? Diethyl ether. A very simple reaction which can easily remember. So it is followed by certain steps. You can understand very easily. So first one is alcohol, CH3, CH2, OH. See, in the presence of a protoic acid, see, proton attracts here due to the presence, and see, we will get protonated alcohol, CH3, CH2, O, and H proton adds here. So this is nothing but a protonated alcohol. See, again it reacts with a molecule of alcohol, CH3, CH2OH, and This is nothing but a protonated alcohol which we already obtained, H and OH. So this attacks here. Are you clear? This oxygen atom. And this water molecule removes. So we will get a protonated ether. CH3, CH2, O, and oxygen. See, hydrogen atom is attached to oxygen. And this ethyl group is attached here. So CH2, CH3. And elimination of the water molecule takes place. See, important steps we have to note down is elimination of the water molecule. And we have in the last step, which is the proton is eliminated. The proton is eliminated and forms the bond. Say CH3, CH2, OH, again CH2, CH3, and this proton is eliminated and bond forms, and we will get ether. Say CH3, CH2, O, CH3, CH2, CH3 plus H plus. A proton is eliminated. So you have to remember this equation, and it is followed by the mechanism. So what is first step one? Protonation of the alcohol. What is the reaction condition here? In the presence of a protoic acid like sulfuric acid. In the whole reaction, you have to remember the alkyl group should not be disturbed. Are you clear? And it takes place at a moderate temperature. If it is temperature is more, dehydration takes place, alkenes are formed. And we are going to take here primary alcohol. If this method is applied for tertiary and secondary alcohol, again alkenes are obtained. Okay, so this is one important preparation which you have to remember, you have to study. So ethers are prepared by heating alcohol at a particular temperature in presence of protoic acid like H2SO4 or H3PO4. It takes place by different steps. Are you clear? Okay. Then we shall continue the next, which is nothing but Williamsons synthesis. It's a very important synthesis of ether you have to study. That is Williamsons synthesis. We shall study Williamsons synthesis. See, Williamsons synthesis of ether. Second method of preparation of ether, Williamsons synthesis. See, Williamson synthesis is one of the named reaction which can be asked for your annual examination. Many times it is asked. See, what is actually the reaction? An alkyl halide with the general formula Rx, when it reacts with a sodium alkoxide, Na1, in presence of a dry ether. Say these sodium and an halogen atom combines, we will get RO plus NaX. A general reaction which is very simple. We can take particular example when methyl chloride is made to react with say sodium methoxide, NaOCH3. So in presence of dry ether, we will get say CH3OCH3, which is dimethyl ether plus NaCl. Particular example. So Williamson's synthesis is used for the preparation of ether. See, what is the reactants? The reactants are, what are the reactants? Reactants are, say, alkyl halide RX and sodium alkoxide. Sodium alkoxide. They react with each other, and RX plus NaOR in dry ether will get an ether. Particularly when methyl chloride reacts with sodium methoxide, and in presence of dry ether, say dimethyl ether. Dimethyl ether is formed. Dimethyl ether is formed. Very simple reaction. Which can be asked for 2 marks. So be familiar with Williamson's synthesis. See, Williamson's synthesis here, if suppose, see, we are going to take an alkyl halide, say COCH3, a tertiary alkoxide ion, CH3, when it reacts with methyl bromide, say CH3, methyl bromide. So what is the reaction product? So we will get, say, here it is an alkyl halide and it is nothing but a, say, methoxy tertiary butyl methoxide. So we will get, say, CH3 would be attached to this. We will get CH3, again say CH3, then OBr and CH3 will obtain. OBr and CH3 will be obtained. Are you clear? Here, not CH3 is ONA, sodium alkoxide. Then we will get, say, sodium tertiary butyl sodium alkoxide. When it reacts with a methyl bromide, we will get CH3, CCH3 and OBr. Say OCH3 plus NaBr. Are you clear? Sodium alkoxide, which is a tertiary ion. CH3, ONA, not CH3. Here it is tertiary butyl sodium alkoxide. Tertiary butyl. What is the name of this compound? Tertiary butyl sodium alkoxide. Sodium alkoxide. Say, when it reacts an alkyl halide, particularly methyl bromide, and we will get, so this NaBr, then again we will get, say, tertiary butyl methoxy group is added there. So it is also like Williamson's ether synthesis. Are you clear? So B concentrate when alkyl halide reacts with sodium alkoxide in the presence of dry ether, the ethers are obtained, and this reaction is called Williamson's ether synthesis. Okay, so only 2 important syntheses you have to study. Next we shall go on its physical properties. See, what are the important physical properties of ethers? In physical property, you have to study mainly solubility, and also you have to study its melting point or boiling point. See, ether, boiling point. Compare the boiling point of ether with that of alkane and as well as alcohol. See, ethers are having more boiling point than alkane or an haloalkane of similar atomic mass, similar molecular mass. Are you clear? Again, alcohols are having more boiling point than ether. See, ether, they can form hydrogen bond due to the presence of oxygen atom. But in haloalkanes, the boiling point is less. As you compare haloalkane or an alkane, the ethers showing more boiling point than respective haloalkane or as well as an hydrocarbon of similar molecular mass. If you compare the boiling point of ether and alcohol boiling point is more. See, due to you already studied the structure of R, which is nothing but O and R dash and ether. So here we can find the oxygen atom, the bond angle is more than that of tetrahedral bond angle. Okay, you have to remember the boiling point of ether is less than that of alcohol of similar molecular mass. Okay, go for solubility. See, alcohol or ether, they are miscible with water. See, how alcohol is miscible with water, in that manner only the ether is also miscible in water. So again, it is also due to the formation of hydrogen bond as oxygen atom is present in ether. Okay, that is the basic thing which you have to remember about the physical properties. In physical properties, boiling point and solubility. Ethers are miscible with water, like alcohol. Okay, we shall study the chemical properties. See, ether reacts with hydrohalic acid. Chemical properties of ethers. We shall study chemical properties of ethers. See, ethers. Chemical properties of ethers. We shall study chemical properties of ether. See, in chemical properties, reaction with halic acid, hydrohalic acid, HCl. That is from HCl or HBr or HR. See, generally ether R, O, R dash, when it reacts with an hydrohalic acid, so we will get R, see, O, H and R, X, and alkyl halide is obtained. Again, say this alkyl halide which is again obtained. Say ROH, again it reacts with hydrohalic acid. So we will get again RX plus H2O. So continuously it reacts with ether and two molecules of say alkyl halides are obtained. Very simple reaction. Two molecules of alkyl halides are obtained. Are you clear? Okay. So, see, this is nothing but a primary alcohol. If it is, take for example, again, tertiary CH3, OCH3, again CH3, again CH3. So, it is nothing but a, see here, COCH3. Tertiary butyl methoxide. See, when it reacts with again, like element sodium iodide NaI. So we will get here, say CH3, again CCH3, again CH3, and see here iodine atom attaches, and we will get CNaI. The reaction we will get here. OCH3 and here you take HI. We will get say CH3OH again plus CH3OH. Say CH3COCH3. when it reacts with hydroiodic acid, we will get CH3, CH3, again CH3 and iodine. See here, this tertiary butoxide ion, it forms by SN1 mechanism, the tertiary butyl carbocation it forms. As it forms tertiary butyl carbocation, see, in the presence of hydroiodic acid, see this iodine attached and we will get iodine, and along with CH3OH, methanol is obtained. A very important reaction you have to remember. I will repeat again. CH3, COCH3, CH3, which is tertiary butyl methoxide. Are you clear? Methoxy tertiary butyl. When it reacts, it is a tertiary ether. If you go for this is nothing but a primary. And if it is a tertiary, then in the presence of hydroiodic acid HR, it favors by SN1 mechanism and formation of carbocation is stable. Here, see carbocation is stable. So therefore, this iodine easily attacks here. Are you clear? Okay. So we will get see tertiary butyl iodide. Tertiary butyl iodide is formed along with methanol. Very, very important reaction. Okay. This is nothing but the reaction with HX, and we shall study how to prepare anisole, preparation of anisole and chemical reactions of anisole, which contains a enzyme. So this is preparation of anisole. See, preparation of anisole. See, it is phenol. When phenol is treated with sodium hydroxide. So we will get sodium phenate. See, ONA. When it reacts with RX, particularly RX. Or we can take methyl CH3X, Cl aggregate, methyl chloride. So we will get easily. So this is nothing but a benzene ring. And see, sodium, which is the more electropositive, we will get methoxy group, CH3 plus NaCl. So this is nothing but anisole. Are you clear? See, it is phenol. Phenol reacts with sodium hydroxide. We will get sodium phenate. And again it reacts with methyl chloride. We will get anisole. Very simple reaction. Okay. So we have to study some of the important reactions of anisole. Important reactions of anisole are, see, anisole OCH3. See this methoxy group which directly attached to sp2 hybridized carbon. So benzene ring is stable. It is electron donating group. It can undergo electrophilic substitution reaction easily. Like bromination, only 3 important reactions you have to study. See, when anisole is brominated, see, bromination. When anisole is brominated in the presence of ethanoic acid, so we will get ortho and para-bromoanisole. We will get ortho and para-bromoanisole. These reactions you are very familiar. See, this is ortho and another one is para-bromoanisoles are formed. OCH3 and here para-bromo. See here major product is para-bromoanisole. If you go for nitration, see when anisole reacts with reacts with concentrated nitric acid in the presence of concentrated H2SO4. Again, we will get same OCH3. Again, para nitroanisole, another one orthonitroanisole, another one is para nitroanisole sulfur. Very familiar reactions. So this is nitration. Always ortho and para products are obtained. Among that, para products are more stable. Are you clear? Even you go for Friedel-Crafts alkylation. See, another important reaction, last reaction which I have to study is Friedel-Crafts reaction. See, when anisole OCH3, when it is treated with methyl chloride CH3Cl. So, what is Friedel-Crafts reaction? What is the reagent we are going to use? So, that is anhydrous aluminium chloride. In presence of anhydrous aluminium chloride, anisole forms toluene. Para, see, we will get CH3, see, OCH3 and CH3 group is at ortho position. In another, CH3 group is at ortho position. That's all. OCH3. Again, it is nothing but electrophilic substitution reaction, like phenols. See, when it again reacts with acetyl chloride CH3COCl in the presence of anhydrous AlCl3. AlCl3, we will get. See, acetophenol, we will get OCH3, again COCH3 plus again a simple reaction OCH3 COCH3. Are you clear? So these are electrophilic substitution reactions of anisole. So according to your syllabus, you have to study three important reactions. That is, one is bromination in presence of ethanoic acid. Another one is nitration. So we will get orthonitroanisole and para-nitroanisole. And last one is Friedel-Crafts alkylation. So we studied preparation of anisole and three important reactions of anisole. So this completes our syllabus: alcohols, phenols and ethers. Dear students, already 50% notes are sent to you, and remaining notes of our nearly 6-page notes I will send tomorrow. See, we practice the reaction. We are successfully completed alcohols, phenols and ethers. Thank you.
ಸಾಲಿಮರ್ ನಂಗೆ ಅದೊಂದು ನೀವು ಗೊತ್ತಾಗದೆ ಇಂಡಸ್ಟ್ರಿ
10 ಗಂಟೆಗೆ ನೀವು ಒಂದು ಚೂರು ಹೇಳ್ಬೇಕು.